So we're getting pretty close. We are now able to have our bird flying around in a reasonably pleasant manner. And we've spawned our pipes and they're moving randomly up and down and steadily to the left. So what we really need to get in now is some collision detection. So we need to know when the bird collides with either the pipes or the ground so that we can end the game. And to do that, we're going to learn about a new variable type. And that variable type is called an enum, short for enumeration. And we use an enum when we want to categorize certain groups of objects. So in this case, we've got essentially two groups. We've got the bird and we've got everything that's not the bird, i.e. the pipes and the ground. And we want to separate those two out and work out when one collides with the other. And we create an enum by using the keyword enum, so not var or let. And I'm going to create a enum called collider type. And this is going to have a type of uint32 or a 32-bit integer. And then we're going to have two different possible values for our enum. So one option is that it's a bird, and we're going to give the value 1 to bird. And the other option is that it's a pipe or ground, and I'm going to give that a 2. And if we had more options, we'd actually double those each time. So the next one would be equal to 4, the next one 8, next one 16, etc., all the way up to 2 to the power 32. So we could have 32 different types within a uint32 enum. And the reason we double it every time is because that enables us to give a unique value to collect together as many groups as we wanted. So for example, if I gave the number 3, that would only be achievable by adding a 1 and a 2. So a 3 would mean birds and pipes or ground. And that actually works with every number as long as you keep doubling every time. But we need to just keep it as a 1 and a 2. So now we need to specify which objects have which collider type. And just before we do that, we need to add a delegate to the game scene class, and that is skPhysics contact delegate. So that just allows the game scene to detect contact between different objects. And I'm going to call this second case object. So it's essentially a pipe or the ground, and I'm going to give it the number 2. And if we had more cases down here, it would actually go 1, 2, 4, 8, 16, etc. So doubling every time, all the way up to 2 to the power of 32. So we could have 32 different cases here with a 32-bit integer. And the reason it doubles every time is because that enables us to use a unique number to represent any group of these cases. So for example, if I gave a number 3, then that would mean bird and object, because there's only one way to make a 3, 1 plus 2. If I gave the number 6, then that would be a 2 and a 4. That's the only way to make a 6 out of powers of 2. So enums are really useful ways of grouping different types of objects together. They're also crucial for collision detection in SpriteKit. Also crucial is adding a delegate, specifically the skPhysics contact delegate, which, as you might imagine, allows the game scene to control and monitor the contact of the different nodes on the screen. So now I'm going to set the various groups for each of our objects. So we'll start with the bird. And I'm going to set 3 different groups, even though we only need 1, just to show you the 3 that are important. So the first one, and the one that we actually need, is bird.physicsBody, and then contact test bitmask. And slightly mysteriously, I'm going to set this to collider type dot object, not bird. And that's because we can only detect contact between objects of the same contact test bit mask. So I'm going to set the contact test bit mask to collidertype.object for all of the relevant objects in the game. And we actually need to convert that to a raw value just to get the types to match up. Okay, so that's the one we need. The other two that's worth being aware of are bird.physicsBody.category bitmask. So this is the category that a node falls into. And for this one, I'll use collidertype.bird.rawValue. And the last one is bird.physicsBody.collision bitmask. And again here, I'll set this to collidertype.bird.rawValue. And the collision bitmask is very useful because it allows you to make clear whether two objects will be allowed to pass through each other or not. And in this game, that doesn't matter because as soon as the bird comes into contact with any of the other objects, then the game is over anyway. So the contact test bit mask kicks in, so we don't need the collision bit mask. But in other games, that's probably not the case. So the collision bit mask is very useful. Okay, so let's just quickly add the same for the ground. So the ground is going to be an object for all of these. Excellent. Then we're going to copy that up to the pipes as well. So we'll have pipe 2, pipe 2, pipe 2, and the same for pipe 1. There we go. So now we should be able to detect a collision between these objects. How do we actually detect the collision? Well, there's a method for us called did_begin_contact. There we go. And this method will be called whenever we have contact between our objects. And we can get the objects that have actually collided if we want to, but we're not actually interested in that here because we know it's going to be the bird and something, so it's going to be game over. So for now, I'm just going to print we have contact. So let's check that out. We should now find that whenever the bird comes into contact with something of the same contact test bit mask, which is essentially either a pipe or the ground, we have contact displayed in the console. Yes, we've got an error here because we haven't defined the physics body yet. So there was actually something that I had in mind to change, and now would be a good time to change it. Is what I'm going to do is define the bird physics body there. Actually, we don't need the texture again, but I will set the isDynamic variable to false. So initially the bird has a physics body, but it's not moving. And then when the user touches, the screen will set isDynamic to true. And that will get over this problem as well because the bird will then have a physics body, so we can apply the various bit masks to it. All right, let's try that again. So here we go on the ground. Yes, I really have run away with myself this time. We haven't, of course, created physics bodies for the pipes, only for the ground and the bird. So let's do that. We need essentially a rectangle to go around the edge of the pipes. And we can do that really easily using pipe1 dot physics body is equal to sk physics body, and we want to create a rectangle of, and then a certain size, and we can just use the pipe texture and get the size of it. And that will just create a rectangle the same size as the pipes. Bear in mind though that this will now make the pipe fall out of the screen under gravity, which we don't want. So we know how to fix that. Let's change is dynamic to false. Notice it will still go through the animation, it just won't be affected by gravity. And then we want exactly the same thing for pipe 2. So let's add that in. And there's actually one more thing we need to do before we run it, and with any luck get everything right. We need to set the delegate within the didMoveToView method, which we do by taking the physics world and setting the contact delegate to what is no longer the view controller, but is effectively the view controller, the game scene. All right, so now when we run the game, we should find that we get collision detection in the console. There we go. So we have contact, we have contacts. Wonderful. You'll notice that the bird is now able to move through the floor, but that's okay, because one of the things we need to do when we get the collision detection is to essentially stop the game. And there's a really easy way to do that. We just set self to get the game scene and speed equal to 0. And that will just stop everything from happening. And everything from moving. So let's see this in action. And everything there has stopped. We do need to make a couple of small changes though, because the user is actually still able to control the bird at this point. So the way I'm going to get around that is by having a game over variable, which is initially false. And then when we have contact, we'll set game over to be true. And then when we have a touch, we'll check to see if game over is equal to false, and only then will we allow the bird to move. Okay, so we now have our fabled collision detection. So we're able to know when the bird hits an object, and indeed we've stopped the game when that happens. Okay, so in the next video we'll be counting the user's score. So we'll be working out how many times they get through those pipes and displaying the user's score for them, and then giving the option to start the game again as soon as they die.